Hello, dear student. How are you? I hope you are doing good and preparing for your exam. So here we are with our question discussion on AIT 7 JEE Main Physics. Again, we have selected some problems that might uh, seems a problem to you. Okay, so we are going to discuss them one by one, see the concept behind that problems, and try to tackle them. So without wasting time, let's just get started with it. Now, the very first question on your screen is, let a small block slides without friction down an inclined plane starting from west, and let Sn be the distance traveled from t is equals to n minus 1 to t is equals to n. Now, in this question, the time limit is given to you as t is equals to n minus 1 to t is equals to n. Then the ratio of the distance traveled has been asked, that Sn over Sn minus. Now, to conquer these types of question, firstly, you must know the concept of, and firstly, you will know the difference between what is Sn and Snth. These are the things that is given to you, Snth or S plus 1th. So Sn means from 0 to 1, 0 to n, whatever be the distance traveled, that is Sn. Snth means in nth second only, what is the distance traveled. Okay, so this is the difference. Like S10th means in 10 second. In 10 second, what is the distance traveled? But in 10th means in 10th second, from 9th to 10th, that 1 second. In that particular 1 second, what is the distance traveled? So the same is the concept here. Now, to know the distance traveled in 10th second, what we will do? To distance traveled in 10 second, we will calculate it by distance traveled in total 10 second minus distance traveled in 9 second. So that will give you the distance traveled in 10th second. In the same way, if I talk about the distance traveled in nth second, the distance traveled in nth second is nothing but the distance traveled in n second minus distance traveled in n minus 1th second. Just one is the difference. Okay. So this is the concept that we are going to use. As nth, all the things is given to you, that block is sliding without friction down an inclined plane starting from rest. So there will be a uniform acceleration in an inclined plane. So we can say that Sn is equals to ut, okay, or you can say instead of nth, this is the concept, but instead of nth we will take is tth. So it will be st into t minus 1. Okay, so this will be more easy for you. Ut plus 1 by 2 times at square, acceleration will be same for both, minus u into t minus 1 plus 1 by 2 a into t minus 1 whole square. Now, in this question, it is given that the motion is starting from rest, which means u, which is the initial velocity, will be 0. So ut and ut minus 1, this term will be vanish out. Only the term that is remaining here is 1 by 2 at square minus 1 by 2 times at minus 1 whole square. Now, if you open this square, what you will have 1 by 2 into a, it will become t square minus 2t plus 1. Now 1 by 2 at square minus 1 by 2, we will multiply this whole term in the inside. So it will become 1 by 2 AT square minus, focus on the sign. So minus minus plus here. It will become 1 by 2A into 2T minus A by 2 or 1 by 2A. Same. Now this and this will cancel out also. So what you have, 2 and 2 will cancel out. You will have 80 into 80 minus A by 2. So STth you will have as what? 80 minus A by 2, or you can say that it is 2 into A T minus A divided by 2, or simply you can take it as A if you can take common, so it will become A into 2A minus 1, sorry, 2T minus 1 divided by, okay. Now an expression we have got, that's at Tth is equals to A by 2 2T minus, this is the expression, A by 2 2T minus 1. Now what we need to calculate, Sn or S plus n plus 1. So what we are going to do, we will put the value of n and n plus 1 in the equation. Now for Sn, put t is equals to n, A by 2 into 2n minus, for n plus 1, A by 2 into 2 times n plus 1 minus 1. So it will become A by 2 into 2n plus 1. Now what is the ratio? Sn and S plus 1 and n plus 1. To take the ratio Sn over Sn plus 1, what you have? You have 2n minus 1 divided by 2n plus 1, because A by 2 and A by 2 will cancel out each other. So this is the relation that you will got. Now, so option C is the correct. Move on to the next question. Yeah. If both the objects start their own their motion simultaneously, when the separation between them is 10 meter, the minimum distance between them is. Now there is a simple concept you can say behind the minimum distance calculation. So what we will do, we will observe the motion of another body with respect to the other body. Okay, there are two body in the system. So we will observe the motion of second body of body B with respect to body A. So what is the benefit of that? The benefit of that will be that one of the body will came in rest immediately. Only another body is moving, and simply you can guess what is the minimum distance between them. Now, if I talk about this question, here VA is given to you as 4 meter per second. This is the, let's say, speed. If I convert it into vector form, so VA vector is nothing but this is x-axis and it is moving in positive x direction. So it will be 4 I cap meter per second. Same we can write for VB vector moving in positive upward direction. So 3 J cap meter per second. Now, I want to observe the motion of B with respect to A. So VBA we are interested in. So VBA means VB minus V. Okay, this is the formula for relative velocity. Now VB is nothing but 3J cap and VA is nothing but 4 I cap. The magnitude of VBA vector is very simple. Square root of both the terms, so it will become 5 meter per second. Now, if you draw it in the vector form, you have VB vector, which is positive, but it is minus VA. So you have to invert the direction of VA, which is given to you. So VA will move in this direction. Now take the resultant of this. So this is the direction of VBA vector. Now the concept is, because now you can fix the point A and this is the initial distance between them, which is 10 meter. And now the B is moving, VBA is moving in this direction, which means VB is moving with respect to A in this direction. Let this angle be theta. Okay. Now how to calculate the minimum distance between them? Just drop from which object you are observing the motion. We are observing the motion from A. So just drop a perpendicular on the relative velocity line. So this will be the minimum distance between them, which is denoted by d minimum. Now, to calculate d minimum, we need to calculate this angle theta. Okay. Now, how do we calculate this angle? This angle theta is between VB vector and VA vector. So if you apply tan theta here, so tan theta would be in this way. Tan theta would be, if I talk about this triangle, this is the resultant. This angle is theta. So tan theta would be VB over VA. Or you can say, yeah, obviously it is VB over VA. So it will become 3 by 4. Got it? Because VB here is nothing but 3, the magnitude of VB, and the magnitude of VA is 4. Okay. So that is the angle between them. Now, so we know that there is a triangle in which 3 is this side, 4 is this side. So this side will be definitely 5. This angle theta here is nothing but 37. Okay. If you apply in this format, if you apply sine theta, so sine theta in this triangle, in D minimum triangle, so sine theta will be perpendicular, which is D minimum, over hypotenuse, which is 10 meter. So perpendicular is D minimum, hypotenuse is 10 meter. Okay. Now, so sine theta, according to this, sine theta will be, because theta is 37 in this angle. Okay, so if you apply sine theta, this would come out to be, this is perpendicular and this is the hypotenuse. Okay, in this way. So it will become 3 by 5. This is the perpendicular and this is the hypotenuse. Now put the value here. So it will become d minimum tan sine theta, tan into 3 by 5, it will become 6 meter. So that would be the correct one. Okay. Now move on to the next one. If vector A vector equals to xi cap, yj cap plus zk cap, then its component along the direction of I cap minus j cap. Okay. So this is a kind of important question and frequently been asked. Easy question, you can say. So now let us try to solve it. So vector A is given to you as xi cap, yj cap plus zk cap. Okay. And another vector, let's say this is vector B, which is I cap minus j cap. Now, there are two methods to solve this question. Firstly, we want the component of this vector in the direction of this vector. So what we can do? We can take the direction vector or unit vector of this vector B and multiply dot product with vector A. So we will get the component of vector A in the direction of vector B. Okay. The another method is, you know that A vector dot B vector will be what? AB cos of theta. Now, if this is A vector, let's say, suppose, and this is vector B, and this angle is theta between them. Now, if you take the component of B vector in the direction of A, this component is nothing but B cos theta. So, B cos theta is the component of B in the direction of A. So, here you can also say that B cos theta will be equals to A vector dot B vector divided by magnitude of A vector. Now, in this equation, we get to know the component of B vector in the direction of A. If I know, if I want to know the component of A vector in the direction of B, so it will be very simple. Multiply with A cos theta, and this will be A vector dot B vector divided by modulus of B, or the magnitude of B vector. Now, in this question, which vector component we have to calculate? Vector A in this direction. So in this question, in this situation also, we have calculated the direction of component of vector in vector B. So this same formula will apply for this question also. Now what we have to do, we need to take the dot product and divide with the magnitude of another vector in the direction of which we have to calculate the component. So to which vector we have to calculate the component? A vector B in the direction of vector B. So you need to divide with that vector in the direction of which you want the component. Now A dot B will become very simple. X I cap and I cap will become X. Y j cap minus j cap will become minus Y. Magnitude of I cap minus j cap will be root 2, because 1 square plus minus 1 square will be 1. So 1 plus 1 will be 2. So it will be X minus Y by option B is the correct. Now the second method, if we talk about the second one, take the, what I am saying, take the unit vector of this in the direction of which you have to find the component. So if you calculate the unit vector of this vector, B cap, so it will be B vector divided by magnitude of B. B vector would be I cap minus j cap divided by magnitude is root 2. Now, if you take the dot product of this vector with vector A, same thing you will be receiving. I cap minus j. I cap and x I cap will x. Y j cap and j cap will be y minus y divided by root 2. So two methods you have in your hand to solve these types of problem. Now, this one, and very important concept we will going to learn by this question. Now, two holes of unequal diameter D1 and D2, which is obviously D1 is greater than D2, also uh, clear with the image of the question and also given in the question, are cut in a metal sheet. Now, if the sheet is heated, and these are the four options. Both D1 and D2 will decrease, both D1 and D2 will increase. D1 will increase, D2 will decrease, and D1 will decrease, D2 will increase. So these are the four possibility, obviously. Now, this is a theoretical question. The solution of it will be also theoretical. Now, always remember this point. First point is that thermal expansion, because this sheet is heated, so it will be expand thermally. Okay, thermal expansion will be there. So thermal expansion will be same as photographic photo enlargement, you can say enlargement or photographic enlargement. Like, we will understand it by an example. Let's say this is the photo. This is the one of the photo we have. Just a second. This photo we have. Now we want to zoom in or enlarge this picture. So what will be? The picture will be same, but the dimension will increase. This one. So this is called the photo enlargement. In photo enlargement, what will be happening here? The second point, the distance between any two point will increase. Okay, you can see it. Here the distance is this between the eyes. Here the distance will be greater. So same thing will be happening for thermal expansion. Thermal expansion is same as the photographic enlargement. So the distance between any 2 point will increase, which means this separation will also increase. This separation will also increase. Hence, the D1 will increase, and same goes for D2, which means both D1 and D2 will increase. Option B is the correct one. So these are the 2 pointers here. Thermal expansion will be same as photographic enlargement, and the distance between any 2 point in thermal expansion, or you can say the photographic enlargement, will increase. So keep these points in mind. Now move on to the next one. Yeah. A body of mass m is lifted up from the surface of the earth to a height 8 times the radius of earth. The change in potential energy of the body is. Now the question statement is made so hypothetical, is made in that way that it confuses the student, because potential energy has a simple expression. Why the question is given in this format? So this is just for to confuse the student. Although it is very simple question, I will tell you when I am solving this. Now, solution of this question will be, we know that because height is 8 times is given from the surface, so you will think in terms of mgh, mg dash h, and that will confuse you definitely. Whenever any question confuses you, go from the very basic. So we know that in gravitation, the potential energy is nothing but minus g m1 m2 upon r. And r is the distance between that m2 and m1, the centers of them. So here we have the earth is the center of earth. This body is firstly placed here. So distance between the radius of earth in between them. Now it is lifted 8 times of RE. This height is nothing but 8 times of RE. So that small r will become 8RE plus RE. Okay, this R. So delta U here is U final minus U initial. U final will be minus G mass of earth into mass of that particular object, which is small m given to you. And mass of earth we will consider capital M. So minus G capital M small m upon R. Finally, it has been 8 times RE, but what I have told you, the distance, this R should be measured from center to center. So it will become 9R minus GM small m divided by, initially it is on the surface, so it will be R. This minus minus will become plus. You can take this GMM over small r as common, so it will become minus 1 by 9 plus 1, because this minus minus will plus 1, and it will become 8 by 9. So the change in potential energy you will have as 8 by 9 times of Gm small m over r. So this one will be the correct one. Okay, look how simple is this. Okay, so move on to the next one. Yeah. During uniform accelerated motion of a particle, initial velocity of particle is 0. Now, these are the four options given to you. Average velocity of the particle is always less than its final velocity. Average velocity of the particle is always greater than its final velocity. That I think cannot be possible, obviously. So you can eliminate the answers by the common sense also. Average velocity of the particle may be 0. Yeah, if the body is returning, then we can say the average velocity has the tendency to be 0, not the speed. And the average velocity of the particle is half its final velocity, which means the exact value is also given. Now, I have told you, whenever the question confuses you, just go deep down in the basics. So we know that with a uniform accelerated motion, the final velocity will be given by u plus a because it is uniformly accelerated. So we can apply the equation of uniformly accelerated motion. So this u will be 0. V is equals to 80. This is the final speed, no, or final velocity, but not the average velocity. Now, what is average velocity? V average, we always say that total displacement divided by total time taken. Let us consider this body which is moving uniformly accelerated. Total displacement is s here, and total time that it will take is t. So from uniformly accelerated motion equation, we can say that s is equals to ut plus 1 by 2 at square. U is given to you 0. So you can say that s is nothing but half at square. Okay, put the value here. Half at square divided by t. Because the distance traveled in t second. So time taken will also be t second. So t and t will cancel out. It will become at by 2. Now move back to the equation 1. At is nothing but the v. So it is v by 2. So exactly V average here is v final by 2, half of the final velocity. Now, if this question is MSQ, this is MCQ, but if this question is multiple select question, so you need to select this question option A because average velocity is always less than its final velocity. But in this question, you can say that V final is half and option D. Okay. So let's just talk about the MCQ. So exact value is given to you and exact option is matching also. So option D is the correct one. Now, move on to the next one. Yeah. In JEE main, you cannot expect a single direct question from the graphs. Okay. So this question is of JEE main level and an intermediate level in JEE main also. Because the graph is not between VT and ST and AT. The graph is between V and X. Okay. So for that situation, we know that the acceleration here is dv by dt. So if I multiply dv by dt, if I multiply this equation ds by ds and take this ds and dt together, so ds by dt will become v and this will become ds. This ds will go this side. So we can say that ads is equals to v dv. Or we can also one thing that we can also find it that acceleration is nothing but velocity into dv by ds or dv by dx if distance traveled is given in terms of x. So slope of this graph, v and x graph, multiply with the exact velocity at that particular point will be the acceleration. So that is the outcome. That is the approach in this question. Now read the question. The velocity of the particle that moves in a position x direction varies with its position x as shown in figure, and its acceleration at x is equals to 6 meters is being given. So it has Very clever, because at 6 meter, the velocity is not given to you also. So you need to calculate the velocity also at this point. So we can make a general point here. And what is that general point? We can make that here the velocity, let's say we have v, and x is also 6 meter. So we can write the coordinate of this point is sorry, 6 and v. Okay. Now, if you calculate the slope of this line, okay, now try to calculate the slope of this line. This coordinate will be 4 and 15. This coordinate will be 8 and 10. You can consider this 4 and 15 to be, let's say, x1, y1, and this would be x2, y2. So we know that slope of a line is given by y2 minus y1, x2 minus x1. Now, y2 minus y1 is 10 minus 15. 10 minus 15 is minus 5, divided by x2 minus x1, 8 minus 4, which is 4. It is minus 5 by 4. You can see here the slope is negative, and also line is also slanting. Okay. It is not like this. So it is also verifying our statement. Now, if you take this line, the line between point 4 and 15 and 6 and v, this also has the same slope. So again, we can equate this minus 5 by 4 with this slope, the line of with the slope of this line. So it will be also, if I this is x1 y1, so we can consider this is x2 y2 again. So y2 minus y1, which means v minus 15 divided by x2 minus x1, which is 6 minus 4, which is 2 to the 4. So it will become 2.5 here. So minus 5 by 2 v minus 15. So if we take 15 this side, 15 minus 2.5, so it will give you 12.5. Okay. Yeah. 12.5 plus 2.5 will give you 15. So velocity at 6 seconds, we have 12.15 meter per second. Got it? Now, this velocity is also decreasing. Now, if we talk about the acceleration, so we know that acceleration we have already calculated by this fundamental equation A is equals to dv by dt. That acceleration at 6 seconds will be slope at 6 seconds and velocity at 6 seconds. So acceleration will be velocity at 6 seconds, we have calculated 12.5. dv by ds, which is the slope at 6 seconds, we have minus 5 by 4. So we know that if you multiply this, this will give you 62.5 divided by 4. Now you will not see the answer here. So what you have to do, you need to multiply, because you see 8 in the denominator. If you multiply it, it will become minus 125 by 8 meter per second square. Option D is the correct one. Got it? Now move on to the next question. Okay, this one. The pressure at the bottom of a tank of water 3p of water is 3p. This is the pressure at the bottom, where p is the atmospheric pressure. If the water is drawn out till the level of water is lowered by 1/5, the pressure at the bottom of the tank will now be. So initially the height and all thing is not given to you. So we will consider that initially the tank is filled up to a height of h. So at the bottom of tank, the pressure will be P atmospheric, which is also P. So P at bottom will be P atmospheric plus rho g h. And this total is given to as 3p equals to P plus rho g h. So rho g h will be equals to 2p. Okay. Now, what is happening here? we drowning out the water till the water level is lowered by 1/5. Now the water level, let's say h dash will be total height h, and how much we have lowered it, h by 5. So now the new level will be 4 by 5 times of h. So now the pressure at the bottom, this is rho g h dash now, because this height is h dash. So the pressure at the bottom, pb dash, will be what? P atmospheric plus rho g h dash. Now P plus, what is the meaning of this rho g h dash? Put the value of h here. H dash is 4 by 5 times of h. So we can say that it is 4 by 5 times of rho g h. And rho g h has 2p. P plus 4 by 5 times 2p. It will become 8p. Take the LCM, so it will become 13 by 5 times of p. So this is the correct option. Correct option is B. Now move on to the next one. A tank and a throw are placed on a trolley as shown. Now water issue from the tank through a 5 centimeter diameter nozzle at 5 meter per second and strike the through, which turns it by 45. This is through actually. This is the through and this is the nozzle. These are same diameter. But the difference here is only that this throw is tilted at an angle of 45 degrees. Now we need to calculate the compression of the spring of its stiffness 2000 Newton per meter, because when the water will come out, it will exert the force on the spring, because every action has an equal and opposite reaction. So when water will come out, it will exert the force in the opposite direction. So it will compress the spring. That force we need to calculate. Now, if we calculate that, what is the force by which this water is coming out? Yeah, definitely that force will be d by dt of p, momentum of the water. Now by d by dt, p we can write mass into velocity. Now in fluid mechanics, we generally write mass in terms of volume and density. So it will be rho into volume into velocity. Rho is constant. So it will become volume flow rate dv by dt into. Now according to continuity equation, this volume flow rate, which is q, is given by area of the orifice or the nozzle multiply with the velocity. Now put the value here. Q here is nothing but dv by dt. So put the value, so it will become rho a v square. Now this force F is rho a v square, which is exerted by the water. But this force has a direction at 45 degrees. Now we need to, because the spring will compress in the horizontal direction. So only the horizontal component of this force, which is exerted by water, will compress the spring. So this Fx is equals to F cos 45 will compress the spring. So this will be equals to Fx is equals to Kx, which is the compression in the spring, or the spring force you can say. Fx we have rho a v square cos 45, which is by root 2, equals to k into x. Now put the value of all the things. This is water, so density will be 1000. Area of orifice, area is not given to you, diameter is given to you 5 centimeter. You need to convert it into meter. So it will become pi by 4 d square, 25 into 10 raised to the power minus 4, multiply by v square, velocity is also 25, divided by root 2 into k. So k is 2000 given. So if we calculate the value of x, it will be coming out as 0.0173 meter. So option is the correct one. Only need to remember that only the horizontal force will compresses the spring. Okay. Now this question, on increasing the length by 0.5 mm in a steel wire of length 2 meter and area of cross section is 2 mm square. Directly the area is given to you. So do not worry about the area, how to calculate it. The force required is Y of steel, which is the Young's modulus of steel, is also given to you. So I will tell you the simple formula to calculate this. Always apply this one. Delta X, which is the extension or compression, is given by F, force applied, original length divided by Young's modulus of elasticity, which is Y, multiplied by the area. Now you need to calculate the force here. So force will be Y A delta X divided by E. Y is given to us 2.2, 10 raised to the power 11. Area is 2 mm square. Now you need to convert it into meter. So 2 into 10 raised to the power minus 6 multiply by delta X is also in mm. So need to convert it into meter also. Minus 3 divided by L. L is 2 meter. This 2 and 2 will cancel out. So you will have 10 raised to the power minus 9. It will cancel the power 11. And these things also, you can write it as 22 into 5, 10 raised to the power minus 2, 10 raised to the power minus 9. From these, 10 raised to the power 11. Now, okay. So, if you multiply it, it will become 1, 1, 5, 5 to the 10, 5 to the 10, plus 1 is 11. Okay. Now, one thing that we are missing here, what is we missing? Just to try to put the value here, just a second. So it is 0.5, 10 raised to the power minus 3 meter. So F, L will be 2 meter divided by Y, which is 2.2, 10 raised to the power 11, multiply with area, which is 2 mm square, which means minus 6. Yeah. Because 1 mm is, 1 mm is 10 raised to the power minus 3. So mm square will be 10 raised to the power minus 6. Okay. So if you go according to this equation, yeah, you are finding the right answer in this way. Okay. So that it will become 1.1 10 raised to the power 2, because this will not be vanish out. 6 and 3 is 9 with this side, and this is the 11. So these two powers will be vanishes each other, because 2.2 multiply with 0.5, it will become 5 to the 10, 5 to the 10, and 1 is 11. 2 point, it will become 1.1. So 1.1 10 raised to the power 2. This you can write. Although you can write it from here also. 1.1 10 raised to the power. You are absolutely correct. So option D is the correct. Okay. Now this one. A body has a weight 90 unit on the Earth's surface. The mass of the moon is 1 by 9 that of the Earth's masses, and its radius is half that of the Earth's radius. So on the moon, the weight of the body in the same unit as used in this case. So it is units is given only, not it is kilogram or Newton or whatever. It is not given to you. So same unit we have to take. Now solution of this one. So we know that weight on Earth is 90 unit here. Okay. We also know that weight on Earth is mass into gravity on Earth. Mass will remain same. Okay. You are traveling to whichever the planet, whichever galaxy you are traveling, your mass will remain same. This is a conservation of mass. Now, if you same talk about the weight on moon, so it will be mass into gravity on moon. Now we know that gravity is given by G m small m divided by r square. Okay. So here you can say that this is gravity of Earth. So GMEM over RE square. If you want to calculate gravity of moon, it will be G mass of moon divided by not M will also not come here. GME over RE square only. G mass of moon divided by radius of moon ka square. Now mass of moon is 1 by 9th of the Earth mass. We can say that G is ME over 9. Mass of moon is 1 by 9th of mass of Earth. And radius of moon is 1 by 2 times of radius of Earth, which is also given to you. Now put the value here. So it will become radius of Earth divided by 2 square and it is by 9, ME by 9. So this 4 will go outside. It will become 4 times 9 gravity of Earth. Okay. Now if you compare the weight, so weight of Earth divided by weight of moon will be equals to mass into gravity of Earth, mass into gravity of moon. Mass and mass will cancel out, mass will remain same. Weight on Earth is 90 unit. Weight of moon we have to calculate. Gravity of Earth is G. Gravity of moon is 4 by 9 times of G. So it will become 4 by 9 into G. G and G will cancel out. So weight of moon will become 4 by 9 times of 90, which is 40 unit. You cannot say it is Newton or what. 40 unit. Okay. So remember this concept, mass will remain constant. Now, this one. Steam is passed into 22 gram of water at 20 degrees Celsius. Now, if the mass of water that will be present when water acquires a temperature of 90 degree, latent heat of steam is given to you, is 99.2 by x. Write the nearest integer to x. Okay. Now, in these types of question, there is a simple concept yet very important, which is principle of calorimetry, which says that heat gain by any object will be equals to heat loss if we neglect the losses in this surrounding. Now, when the steam, which is obviously at 100 degrees Celsius, the assumed temperature of steam will be 100 degrees Celsius. So when the steam of 100 degrees Celsius pass through a liquid, which is water, and at 20 degrees Celsius, so definitely it will going to lose heat because of the temperature difference. So when it is losing heat, that steam will convert it into water. Okay. That steam will condense and convert it into water. Okay. So some of the mass of steam will convert into water because of heat loss. So heat loss we will calculate first. Heat loss will be, let's say m mass of the steam will be lost, multiply by when the phase transition is happening. So we will use the latent heat. So m into 540. And it is given in calorie per gram. So all the unit we will take in calorie per gram, in calorie and gram. Okay. Now this is m into 540 plus the same mass, because this steam is now, firstly it is a steam, it was a steam at 100 degrees Celsius. Now when it is converted into water, m amount of it converted into water, this will also be in the same temperature, because we know that in phase transition the temperature will not change. So that water will also lose heat, because the water in which we are mixing the steam is at 20 degrees Celsius and this water is at 100 degrees Celsius. So now it will lose heat as mc delta T. So C will be the specific heat of water, and that specific heat of water, and that will be given by 1 here, because in calorie it is 1 calorie per gram degree Celsius. Okay. So m into 1 into temperature difference is 100 minus 90. What it? 100 say we have to go 90 degrees Celsius, because water has acquired a temperature of 90 degrees Celsius. Heat gain, heat is gained by this 22 gram of water, because in which we are mixing the steam, na? The water is at 20 degrees Celsius. So 22 gram, one is the specific heat, and the temperature difference will be from 90, because final temperature is 90 and initial it was 20. If you equate this equation, it will become 550 m. This will be 10 plus 540, so 550 m into 20 into 70. So m will be, you have 20 into 70 divided by 550. 0, 0 will cancel out. 11 to the 22, 11 5 is 55. So it is uh, 14 by 5, which is 5 to the 10.8 gram. So that will be the increase in the mass. This is the steam, which is converted into water. So final mass we have 22 gram plus 2.8, 24.8 gram, and which is given to you as a in this way. So this 24.8 is given to you as 99.2 divided by x. So if you make the calculation, x will be here approximately 4. This is the nearest integer that we have. Okay. So concept is heat gain is equals to heat loss. Now move on to the next one. Yeah, this one. In the figure shown, all surfaces are smooth and force constant of spring is 10 Newton per meter. Okay. Block of mass 2 kg is not attached with the spring. The spring is compressed by 2 meter and then released. This line is said because when we release this, it will not stuck to the spring. It will be freely moving. The spring is compressed by 2 meter and then released. Find the maximum distance d traveled by the block over the inclined plane. Take g is equals to 10 meter per second square. Okay. So firstly, we will take because this is the smooth surface. So we can apply the conservation of energy also, or by the work done, you can also say work energy theorem. So by principle of conservation of energy, you can say that kinetic energy initial, potential energy initial, kinetic final, potential final. Now kinetic energy initially 0, potential energy initially 0, obviously they are in rest. Finally, no, you cannot say that initial kinetic energy is 0, because initially we will take the situation when it is compressed. Okay. So that energy is given by 1 by 2 times kx square. Now the final potential is zero because spring now it is in natural length. So final potential energy is zero. But the final kinetic energy that will be gained by this block is half mv square. This 2 and 2 will cancel out 1 by 2. So K is given to you 10. X is 2 into 2. 2 meter we have compressed it. Mass is also 2 kg. So velocity will be here v square. 2 and 2 will cancel out. So velocity is root 20 meter per second. Now you will wondering that what kind of answer is this? When the root 20 will not be the answer. Obviously, root 20 is not the answer. Now we need to calculate the distance traveled over this inclined plane. On this inclined plane, when this acquired this velocity, this is start climbing on this inclined plane with this velocity. So when this velocity will become zero on this inclined plane, then we can say the maximum distance is this. Okay. Now, one of the fact here is that here the gravity will act in the opposite to it. That is why the velocity will be decreasing constantly. So that gravity G, and that is nothing but the weight of the block mg. So the force will be acting in this way, in the opposite to this motion, which is mg sine 30. And according to Newton law of motion, F is equals to ma. So F here is mg sine 30 equals to ma. So acceleration here will be what? Acceleration here is g sine 30. Now this acceleration is a constant acceleration and all the surfaces are smooth, so we can apply the uniform accelerated motion equation. This will be S is equals to ut, or not in terms of time, in terms of distance and velocities also. V square is equals to u square minus 2as. Why minus? Because this acceleration is the opposite to the motion. So the final velocity will be 0 for distance to be maximum. U square, or you can say this V is U. It is root 20. So square will be taken as 20. Now you got na why this is root 20. Equals to 2 into acceleration, which is g sine 30. G is 10, sine 30 is 1 by 2. S 2 and 2 will cancel out. 0 and 0 will cancel out. So S, or the distance traveled, you will have as 2 meter here. This is the answer. Okay. Now, this one. So this will be the last question of this session. Two particles, each of mass m, are connected by a string of length 1 meter. But in the figure, if you will see, the length is only 0.5 meter. Because in this way, the string is crumbled, not in a stretched position. The particles are kept on a smooth horizontal plane. The initial separation between the particle is 0.5 meter. One of the particle is given a velocity 18 meter per second as shown in figure, vertical direction. Find the magnitude of angular velocity of one of the particle with respect to the other particle just after string become taut. So we know that initially it is like this. The separation between them is 0.5 meter. Although the actual length of the string is 1 meter. Now we fix this particle small m. Another particle is also small m. And it has given a velocity 18 meter per second in the vertical direction. So this will keep on moving. The string will keep on increasing. The length will also keep on increasing. Okay. So we will consider that at a particular angle, this string become taut or tight. Okay. And this is the direction of velocity v, let's say, which is given 18 meter per second. And this angle, we will say this angle is, let's say, theta. So at theta angle, the string will become taut. Now we can say that if you resolve this, now this will be the simple question of circular motion. So for circular motion, because angular velocity is being asked, so you need to calculate the component of velocity which is perpendicular to the line joining them. or you can say the tangential component. If this will be the circular motion, this component is the tangential component. If this angle is theta, this angle would be 90 minus theta, which is, let's say, and you can also calculate this angle. This length is 1 meter because now the string is at full length. String is taut, so it is at full length. So full length of the string is 1 meter. This is 0.5 meters. So if you apply sine theta or cos theta here, so cos theta will be based upon hypotenuse 0.5 by 1, 1 by 2, which is cos 60. So this theta here is 60 degree. If this is 60 degree, this angle will be 90 minus theta, so it will be 30 degree. Same angle will be here. This will be 30 degree. So if you resolve, this velocity component will be v cos 30. Now it is very simple. We can say this is the radius of this circular motion for that instant only. So v is equals to r omega. V here is v cos 30. R here is radius, which is 1 meter. Omega we need to calculate. Omega will be v cos 30. V is 18. Cos 30 is 1 by 2. So omega you have as 9 radian per second. Look how simple is this. That the concept here is when the string become taut, it is in actual length. Okay. So this is it from my side, guys. Hope you will enjoy this session. Any kind of extra doubt other than these questions, you can talk me and you can get me in the regular classes also. Okay. So thank you so much. Take care of yourself. Bye-bye.